Let us look at proposition number 26 of book 11 of Euclid's Elements. The proposition says to construct a solid angle equal to a given solid angle on a given straight line at a given point on it. So here we are given a solid angle D and a straight line AB, and at A we have to construct the solid angle which is equal to the solid angle D. So let's proceed of how to construct. Now, first thing we do is we take this length AB and we cut this line so that it is equal to AB. So let's do that. We draw a circle of radius AB, take the intersection. So now DE is equal to AB. Now we take a random point on this elevated leg of this solid angle. Now here these two lines are on this plane. Let's call this as plane of reference. And this is elevated. On this elevated line, we take a random point, F. And from F, we drop a perpendicular to this plane of reference. If I rotate it, you will see that it is perpendicular to the plane. And now we mark the point of intersection of this line with the plane. So let that be G. Now we join EG and extend it so that it intersects the third leg of the solid angle. So EG. And we mark this point of intersection as C. And now let's join these points and let's get rid of these continuous lines. Now that we have completed this part, now basically what we are doing is we are copying this solid angle to A by individually copying various angles. So first is to copy EDC, angle EDC to A on AB. So we draw a circle with center A and radius as CD. And we draw a circle with center at B. Let me rotate it so that it becomes clearer. Center at B and radius as CE. And we take the point of intersection as L. Since the smaller circle is centered at A and the radius is a CD, so AL will be equal to CD. Let's join them and let's get rid of these circles. Now the next thing that we do is copy the angle EDG to A on AB. So same process. Center at A, radius as DG, center at B and radius as GE. Take the point of intersection. So which means since KA, that is the radius of this circle, and this circle is centered at A and the radius is DG, that means DG is equal to KA. So let's join KA and let's hide these circles. So angle BAL is equal to EDC and angle BAK is equal to EDG. Now we join BK and we join LK. And now we take a perpendicular line perpendicular to this plane from K. So let's draw that line. And on this line, we cut off a segment equal to FG. So we draw a circle of radius FG with center at K. And we take this point of intersection. By the way, remember, this circle has to be drawn on the plane perpendicular to this plane. So let me briefly show you that plane. Now let's mark this point of intersection as H. And let's hide this circle and the perpendicular plane and the perpendicular line. And let's join KH. And now we join L with H, A with H, and B with H. So now the construction is complete. The solid angle at A contained by BAL, BAH, and HAL is equal to the solid angle at D. But we have to prove that, right? So let's take it step by step. Now remember, in the beginning, we cut off the straight line, a segment DE equal to AB. FG is perpendicular to BG and GE. Why? Because FG is perpendicular to the plane. That means it is perpendicular to all those straight lines which are there in this plane and meet FG. Similarly, we have here HK is perpendicular to BK, AK, and LK. Because HK is perpendicular to the plane, that means it is perpendicular to all those lines which meet it and are in this plane of reference. So FG is perpendicular to DG and GE. So what do we have? We have KA is equal to DG. AB is equal to DE. And angle AKB is equal to BGE. So we can say that triangle AKB is congruent to BGE triangle. So let's color it off. So these two are congruent. Now if these two are congruent, what does that mean? It means BK is equal to GE. Now let's look at the next part. Now KH is equal to FG. BK is equal to GE. Just now we proved that. And angle HKB is equal to FGE. That means triangle HKB is congruent to FGE. HKB is congruent to FGE. That means what? That means BH is equal to FE. Now, AK is equal to DG. KH is equal to FG. And angle AKH is equal to DGF. That means triangle AKH is congruent to DGF. So let's again color it off. So since they are congruent, it means what? That AH is equal to FB. AH is equal to FB. Just now we proved that. AB is equal to DE and HB is equal to FE. That means triangle BAH is congruent to EDF. Since they are congruent, that means angle BAH is equal to angle EDF. So let's color off those two triangles also. So if you notice, one part of it we have completely proved that they are congruent. Similarly, we can prove that angle HAL is equal to FDE. C, and angle BAL is equal to EDC. So which means that angle BAL is equal to EDC. Angle BAH is equal to EDF, and angle HAL is equal to angle CDF. So if you notice, the solid angle at D is equal to the solid angle at A. So we have constructed a solid angle from a given solid angle at a given point on a straight line. So that was proposition number 26 of book 11 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.